My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 539. In this lecture, we will try to understand notation. We have seen in the previous video that multi-layered structure is an extremely powerful idea to build extraordinary powerful models. I am trying to come up with a very simplified notation. Let's assume our input is like this: xi1, xi2, xi3, xi4. My data set is capital D equal to xi comma yi. Let's use regression problem because they are the regression problem is easy for differentiation. Regression problem is easy to understand. Let's assume xi belongs to R4, means it is 4-dimensional point. Let's say my yi belongs to R. So what we are solving here, we are solving regression problem. We are using regression because maths and stats become easy to follow. So let's go back to the notation. My xi belongs to R4. R4 means it's a 4-dimensional point. It belongs to 4-dimensional. Means what are these dimensions here? xi1. What is xi1? Is the first feature of xi. xi2 is the second feature of xi. xi3 is third feature of xi. xi4 is the fourth feature of xi. So this is how I represent each of these features xij, where I is the point index. Which point it is? I is the point index. Xij means ith point. I index ith point. J is the feature, isn't it? Feature of the dimension, I can say. Let's assume I have I have these inputs and I have 3 neurons, isn't it? Let me assume I have 3 neurons here, and all of these points are connected. Just let me assume these are connected like this. If it is the case, this xi1, xi2, xi3, xi4, what is this? This is my input layer, isn't it? What is this? This one, this neurons is first hidden layer, isn't it? In layer 1, what is this? This is first hidden layer. Let me assume it's layer 1. This is function 1 in f11 means what? Function 1 in layer 1, isn't it? This is function 1 in layer 1 corresponding to this neuron. f11 is neuron. f12, what is this? f12 in layer 1 function 2. f12 means what? Layer 1 function 2. f13 means layer 1 function 3. We are just giving numbers here, so that it is easy for us to follow. Now let's assume I have 2 more neurons here. Just let me assume in layer 2, isn't it? Outputs are connected like this. Just see, outputs are connected. Let's assume both of these are connected. Just see. Yes. Now this layer 3, what is here? Layer 3 is output layer. The layer 2, there are 2 neurons which are connected to layer 3. So following the same notation, what is my f11? f11 means layer 1 function 1. f12 means layer 1 function 2. f13 means what? f13 means layer 1 function 3, isn't it? In similar manner, f21 layer 2 function 1, f22 layer 2 function 2. f31, what is my f31? This is layer 3 function 1. This is my yi cap. I have yi cap here. The ideal output is yi, isn't it? What is our ideal output? Ideal output is yi. The ideal output that I want is yi. Model will output yi cap. If yi is similar to yi cap, then you have done a terrible job or brilliant job. Now the next thing is the output of each of them. What is the output of each of them? Whenever I say Fij, what is Fij? Fij means what? I is here. I here represent layer number. J here represent function index, isn't it? I is layer number, j, what is my j? J is function index, isn't it? Just see this one. What are the outputs? O11, O11, and what is the output? Here you have got output. This is output O11 from F11. This is O11 as this. These outputs are just I am giving same number. Here 11 means output. Here I am giving 1. Here this neuron, this is F12. What are the outputs? O12. Just see O12. I am writing same number. Here I have 12. I am writing 12. F13. What are the outputs? 1313. Just try to understand these numbers. Here I have 11. I am writing 1111 from this particular neuron. Here I have 12. Just I am writing 1212. Here I am 13. Here I am also writing 13. It's simple thing. Anybody can understand. What is OIJ? What is the meaning of OIJ? In the same manner I am writing here. Just see what I am writing here. Here F21 output. I am writing same 21. Here 22. Just I am writing 2. What is OIJ? What does it mean? OIJ. OIJ is the output from ith layer. What is OIJ? OIJ is output from ith layer and jth neuron. Just O21 output from ith layer. I means what? 2, j means 1. Ith layer, second layer. Yes, ith layer means from second layer, and jth neuron. Jth neuron means which neuron? This is first neuron. That's what it says. OIJ represent output. For example, O11. This is output from ith layer. Ith means 1, first layer. Yes, this is first layer. This is output of first layer. And jth neuron. J means what? 1. From which neuron? This is first neuron. Isn't it? It's simple. OIJ means this is output from ith layer and jth neuron in that layer. Isn't it? Jth neuron in that layer means in corresponding. O11 in that layer means this layer. Something like that. I think it is simple and straightforward. That's what OIJ means. If you look at the perceptron, there are weights associated with it. Each of these weights has W1, W2, W3, isn't it? What was our goal? Our goal is to find these weights, isn't it? Let's put weights even in multi-layer perceptron. Let me put weights as W11 superscript 1. If I have a weight Wij whole power k, let me write this is Wij whole, this is k. What does it mean? What does this mean? K basically says what is the next layer. This k indicate what is the next layer. Here what is the next layer? Next layer is first layer, layer 1. 1 means what? This is layer 1. What is the next layer? K indicates, basically says what is the next layer. Let's take this edge. Let me assume, yes, let's take this edge. What is this? Just see, if you observe this one, what is the next layer? This is the edge, isn't it? What is the next layer? Next layer is second layer. Just see, this layer is second layer. From which one? From second neuron to first neuron. This is second neuron in this particular neuron. To which neuron it's going? First neuron. Just say this one. What is the next layer? Next layer is layer 1. From which input to which output? From first. From first to, again this one is first in this particular layer, isn't it? Let's take what is the next, as I told you here, what is the next layer? In this particular example, next layer is 2. That's why I'm keeping 2. I will put next layer as its superscript. Why am I keeping this 2? I am keeping next layer is 2. I will put next layer as superscript. The first value I is from. This is from, isn't it? This is 2. Yes, means to next layer is second layer. From second input to second input to first input. This is Wij whole power k means what we were saying. We are saying that k basically says next layer, this from this is 2, isn't it? That's what it says. It is the weight going into the weight going into the second layer. It is going from second neuron. It's going from second neuron to first neuron, isn't it? That is W21 whole to the power of 2. That is superscript, isn't it? That anybody can understand. Let's write from xi3 to f12. What is xi3 to f12? How can I write? Which layer it is going? It is going into layer 1, isn't it? It is going into layer 1. So put 1 in superscript, w power 1. What we have to keep in subscript? From and to. In subscript I must keep from and to. From where it is going? It is going from third input. It is going from third input here. And where it is going to? It is going to second, isn't it? So I must write W32 whole power 1. Consider this it's going to let me consider another one. It's going to third. It's going to layer 3. What is the neuron number in layer 2? Neuron number in layer 2. What is the? You just see here. If you observe this one, it is going to third layer. From which neuron? From second neuron. This is second neuron. To which neuron? First neuron. Anybody can understand. It's simple notation. Let's take one more example. Xi2 to f12. What is Xi2 to f12? Which layer it is going? It is going to layer 1. It's going to from which input? From second input. To which output? To which this one? Second output. Isn't it? Which layer it is going into? It is so 1 is superscript. What is about subscript? It's going from second input to where it is going? It is going to this particular neuron. Therefore I am writing from 2 to 2. Yes, this is how you index this. This is how you are numbering each of these values. So you have number to input, you have number to each of these neuron functions, number to each of outputs, and you have the weights, isn't it? You have the weights that to give. It is just the notation introduction. Once you get the notation, then maths becomes easy. This is very important. When I say Fij, what is the meaning of Fij? Fij, when I say Fij, I is the layer. What is this? I is the layer in which it resides. I is the layer in which it resides. In which it resides, isn't it? And J is the index from the top. Just say Fij. I is the layer. In which layer? First layer. Index from the top. J is index from the top means what? Just say J is the index from, this is first layer, index from top, 1, 2, 3. Isn't it? Something like that. Oj is the output of Fij. What is my Oj? Oj is output of Fij. Isn't it? What about weight? Weight means we are saying that W power K Ij. Isn't it? What about weight? K. What is my K? K means next layer. Isn't it? I means from. J means to. Isn't it? From Xi4 to F13. What is the Xi4 to F13? Just see. This is K. K means it's going to first layer. From which? From fourth input to third output, like this. Isn't it? Wij from this to this. It is simple notation. I think I would recommend that draw it on paper and practice this numbering a little. Now let's take this let's take this F12 to F2 to it's going into layer 2 from second just see this one F12 to F12 to F21. What's happening here? From second neuron to second neuron. This is from second neuron to F12 to, just let me assume this one, F12 to F2, let me consider this one, otherwise just say F12 to F22. What is this? It is going from layer 2, isn't it? It is going from layer 2. Therefore, what will I write this one? This one I would write W2 to power 2. Why? Because it is going to layer 2. It is going to layer 2. I am considering F12 to F22. From this to from this. Isn't it? It is going to layer 2. Therefore, I am keeping 2 here. From which one? From which input? From second input. To which output? From to second output. Therefore, it is W2 to whole to the power of 2. This is how we get the this is how we get the weights. Now look at it. I think I redraw it again. Let me redraw it again. Just see. I think I redraw it again. I have 4 inputs: xi1, xi2, xi3, xi4, and I have 3 neurons here. Here, how many neurons? I have 3 neurons. This one, this one, this one. Isn't it? Yes. What are the neuron numbers? F11, F12, F13. I have 2 neurons here. What are this? F21, F21, F22. And last neuron. What is my last neuron? F31. Just let me connect all these neurons. If I connect, what will I get? This one. Isn't it? So this is my input layer. From input, this is, you know that this one is input layer, isn't it? I am making all possible connections that are possible. So from one layer to next layer, I am connecting all possible vertices. Similarly, all possible connections from one layer to other layer. Just see, from this particular layer to this one, I am keeping all possible connections. From here to, from this one, let me say, from this to from this, all possible connections I am making. All from this to from this, all possible. From here to here, from here to here, all possible, isn't it? All possible connection from one layer to other layer, because connection can go from one layer to the next layer. Connections can go from one layer to the next layer, not within the layer. That within the layer is not allowed. So I am doing all possible connections. So such a network, you are making all the possible connections. Such a network is called, you are making all possible connections is called fully connected neural network or fully connected multi-layer perceptron, because you are making all the connections that are possible here. We can only connect from one layer to other layer. Here you have how many inputs? You have 4 inputs and 3 neurons here. What are the possibilities? All the 12 connections. Therefore, how many possible connections here you will get? You will get 12 possible connections, isn't it? You can find similarly here you have 3 neurons. Similarly here, how many neurons? Here you have three neurons, and here you have 3 neurons, here you have 2 neurons, isn't it? How many possible connections? 3 into 2, 6 possible connections. So we have done, for example, here you have 2 neurons, here you have 1 neuron. Therefore, how many possible connections? 2 connections here. So you have 2 possible connections here. All the possible connections are connecting, and hence it is called fully connected neural network. Now let's look at it from the perspective of first neuron. What is the perspective of first neuron? Just if I connect like this, just see what are Wij whole power k. Wij whole power k means what? Power k means this is to which layer? This is layer 1. This is layer 1. It's going into layer 1 from to. From means first one to, it is going to first one only. This is first one to second one. It is first one to third one, isn't it? That's what I am writing here. Just see. Just I am representing this is as first row. All these connections are first row, isn't it? In similar manner, for this is second row. This is third row. This is fourth row. Just see. That's what I am writing here. Just see this one. What it says. This is W 2 1 means from second input to first output, something like that. From 2, from what? From 2. 2 1 means what? W, what it indicates? W21 whole power from second to first. This is second. From second, isn't it? W2, this is second, isn't it? W21 to first. To first means what? This is. Power 1 means what? This superscript indicates to which layer. It is going to first layer. Just I am representing this as second row. Just I am representing this is first row of W power 1. This is second row of W power 1, third row, fourth row. Just see, you can see the connections here, isn't it? What is the order of this particular matrix? There are 4 rows, 4 inputs and 3 outputs, therefore 4 by 3 matrix. This is entire weights from input layer to first hidden layer is represented in the form of a matrix, that is W power 1. In similar manner, I can represent a matrix from layer 1 to layer 2. It is W power 2. What is the order of that particular matrix? That particular matrix order is 3 by 2. In similar manner, I can represent weights from this to this. From which layer? From this layer to this layer, I can represent it as W power 3. This is order. Inputs, you have 2 inputs, 1 output, that is 2 by 1. Here you have 3 inputs, 2 outputs. I am writing 3 by 2 matrix. Here I have 4 inputs and 3 outputs. I am writing 4 by 3 matrix. Isn't it? It is simple and straightforward notation. I request all of you to go through this notation so that in my next lecture, I will start training a single neuron model. Thank you very much.